In this presentation, I am going to give an introduction to the power electronics. In that one, what are the different power electronics switches and what are the different application of power electronics devices that I'll be explaining. Coming to the power electronics systems. This is the block diagram of a power electronics systems. Basically, power electronics deals with the use of electronics for the control and conversion of electric power. That is used to control the power flow as well as convert the electric power. For it is used for control and conversion of electric power. That is the electronic that is used for control and convert the electric power. That is basically it is called power electronics. And this is the block diagram of a power electronic system, in which the main heart of this system is, the block diagram is the power processor or power modulator. That consists of power electronic switches like uncontrolled switch diode or semi-controlled switch like silicon control rectifier or fully controlled switch like MOSFET, IGBT, etc. Apart from that one, the energy storing devices like inductors, capacitors, and the energy dissipating element resistance. All this will be constituting the power modulator. This is the main block diagram block of this power electronic system, in which the input to the power electronics power processor or power modulator is the input power, electric power, that can be either AC or DC, and the output of the power processor is given to the load. This can be either motor load or a battery load, whatever it is, and the output of this power modulator, that is measured using a transducers, and that is compared with the reference value, and the error is taken, and in order to minimize the error, we are giving the control signal to the power modulator or power processor that will be control the power flow from the source into the load. Now, power processor unit or power modulator consists of power semiconductor switches, energy storing elements like inductor, capacitor, and the energy dissipating element R. And controller means controller consists of linear integrated circuit LICs and digital signal processor that will be constituting the controller. Therefore, this is the basic block diagram of a power electronic system, in which the power flow from the electric source, that is either AC or DC, that is controlled to the load. Now, if you coming back to the type of the source, maybe it can be either DC or AC, and the load can be either AC or DC. Consider that if the input is a DC source and the motor is an AC motor, then the role of the power modulator or power processor is it is an inverter that converts the DC into the AC. That is the role of the power modulator. Now, rather than if the motor is a DC and the source is a DC, then the role of the power modulator or power processor is a chopper. It's a DC to DC converter. Therefore, depending upon the type of the source and the type of the load, the role of the power modulator or power processor changes. Now, we are going to compare power electronics and linear electronics. Bipolar junction transistor can be used either as a linear electronics device or a power electronics device. In linear electronics, generally bipolar junction transistor are used as an amplifier, and it is operated in active region. When BJT, bipolar junction transistor, used as a linear device, it is working in active region and it is used for amplification. In power electronics application, when you are using the bipolar junction transistor as power BJT, power bipolar junction transistor, it is used as a switch. It will be either on or off. That is, it will be operating either in saturation or in cutoff. Therefore, the BJT can be either it can be operated as a linear device, linear circuit device, or it can be operated a power electronics device. When it is operated in linear circuit device, it is working in an active region, and when it is working in a power electronics device, it will be either in saturation or in cutoff as a switch. Therefore, when BJT is operated in active region, the power dissipation is given by VCE into IC, that is collector to emitter voltage into the collector current. Therefore, the power dissipation will be very large when it is operated in active region, or the power Therefore, when BJT is operated, but when as a switch, when it is in power electronics medium, that is BJT will be operated either in cutoff or in saturation. The power loss will be less. Therefore, when bipolar junction transistor is used in as a power electronic device, the power loss is less, because either it will be working in a saturation region or in cutoff region. Therefore, when it is working in a saturation region, the VCE will be almost very low. Similarly, when it is working in a cutoff region, the collector current is very small. That is why the product VC into IC will be very low, or power loss is very minimal or very less when it is working as a switching device or power electronics device. But when it is operating as an amplifier, like in a linear electronic device, then power dissipation will be more. Therefore, the BJT itself can be used as either a linear electronics device or a power electronics device. When it is used as a power electronics device, power dissipation is less, and when it is used as a linear electronic device, the power dissipation is more. Therefore, in linear in a linear power supply system, what we are using in the lab, the linear power system LPS, here you can see that input voltage is first stepped down by using a transformer which is operated at line frequency, and the output of this transformer is rectified using a full wave rectifier, and that is filtered using a capacitor, so that we will be getting a fixed voltage at the output of this capacitor. And we want to regulate the voltage at the load. This is the load. You want to regulate the output voltage independent of the variation of the input voltage as the load current. Therefore, you want to regulate. For that one, we'll be using the linear power supply LPS. In that case, the switch what we are using is the transistor. The transistor, bipolar junction transistor, this is working in an active region. When it is working in an active region, it is working as a variable resistor, because the difference in voltage, whatever the voltage you want here, that is given as a reference voltage, and the actual voltage is measured based upon the error given to the base drive circuit. To reduce the error, you are driving the base in such a way that the actual voltage is same as is brought to the reference voltage. Therefore, the difference in voltage, the voltage at the input side and the output voltage, that will be dropped across the collector to emitter of this transistor, and there will be a power loss. Therefore, it is working as a variable resistor. Therefore, in a linear power supply, the transistor is working as a linear electronics element. That is, in that case, it is working in active region and it is working as a variable resistor. Therefore, there will be a power loss in a linear power supply. Continuing the introduction of power electronics, as I already told, power electronics involves the application of electronics on control and conversion of electric power. And basic block diagram, one more block diagram is shown here. In that one, source is there, as I already explained in the previous slides. Electric source is there, that can be either AC source or DC source, and the load is maybe the mechanical load that is driven by a motor, and there's a power modulator. The power modulator output is given to the motor, and to the input of the power modulator is the AC or DC source, electric source is given, and we have to sense the parameters to be controlled, like either maybe the speed of the motor or maybe the current of the motor, whatever it is, that is sensed, and that is using the sensing unit that is sensed, and that is given as a actual value, and that is compared to the reference value, and based upon, to reduce this error between this one, we will be giving the control signal to the power modulator. Therefore, power modulator controls the power flow from the source into the motor. Depending upon the type of the source and the type of the motor, the power role of the power modulator will be changing, as I already explained. It may be if input is an AC source and the motor is an DC motor, then it is a AC to DC or control rectifier. It is a control rectifier. And if the input is AC, if the input is DC and output is a AC motor, then the role of the power modulator, it is a inverter. Therefore, that will be inverter. And if the input is a DC and the motor is a DC, let's say DC, we have to control the power flow from the fixed DC into a variable DC, or it's a DC to DC converter, that is called the chopper. Therefore, depending upon the type of the electric source as well as the load the motor, the type of the motor, the role of the power modulator changes. It can be either inverter or it can be chopper. or it can be rectifier, or it can be AC to AC controller, like that cycloconverter, etc. Therefore, the power flow between the DC or AC source and the motor can be controlled by using the power modulator. Therefore, the power modulator or the power processor consists of, as I already explained, power electronic switches and elements like energy storing elements like inductor, capacitor, and dissipating element are. And the control processor that consists of linear integrated circuits and a digital signal processor. Therefore, this is a another block diagram of a power electronics system. Now, coming to the application, what are the application of power electronics? Power electronics has got a very large fields of application, like as I told you, because power electronics is control and conversion of electric power. If you are seeing that industrial application, in industries is widely using like motor control, then in textile mills, rolling mills, then of course the cement mills, paper mills, etc. In different industries, it is widely using for controlling these type of motors. It is used for controlling the motors. Another the industrial furnace, welding, blowers, fans, pumps, etc. Everywhere we are using the power electronics switches. Then commercial applications also it's widely using for heating applications like heating application, then air conditioning in computers and office equipments like UPS, uninterrupted power supplies. Then we have seen elevators, etc. In different office or commercial applications also, it is widely using the power electronics devices are using. Then industrial application, commercial application, then residential applications also using in houses like air conditioning that requires power electronic switches and devices, like for cooking it is used. Then induction cooking, different types of cooking gadgets or equipment that is using. The lighting purpose it is using, refrigerators it is using, washing machine it is using, etc. For different residential applications, power electronics are widely using. Okay. The another one is the telecommunication application, like especially for that one, battery chargers and uninterrupted power supply that is required in the case of telecommunication application. Then transportation it is used, widely it is using transportation, like battery charger is for the traction purpose, that is traction control of the electric vehicles it is using, transportation purpose it is using. Then aerospace application it is using, space shuttles, and the power supplies for the aircraft, etc. power system, that is all there also we are using the power electronics switches and devices. Then utility system like a high voltage DC transmission system, then fax devices like flexible AC transmission system devices in the power system to enhance the power transferring capability, we are using the fax devices. Everywhere in all these fields we are using the power electronics devices and power electronic switches. Therefore, industrial application is there, commercial application is there, residential application is there, telecommunication application, and the transportation and the aerospace application, and different utility systems we are using power electronic switches and devices. Just to show the application, just as a pictorial wise, the UPS, uninterrupted power supplies, power electronics devices, switches are required. And the speed control of motor, we require the of course rectifiers, inverters, stoppers, etc. different are used, and we are using depending upon the type of the motor. Then welding machine it is using, then power supplies we are using, and then induction heating it is using, then plasma cutting machine, because in a lot of things, just I have shown a few examples only, power electronics are using in most all applications of this, both industrial, residential, transportation, telecommunication, space application, etc. Let us see the classification of power electronic switches or power electronic or semiconductor switches. Power electronics involves the application of electronics on control and conversion of electric power, and the classification of semiconductor or power electronic switches, it has broadly three types it can be classified. Uncontrolled switch is the diode, it's an uncontrolled switch, it's a semiconductor switch. It can on and off, that is controlled by the power circuit. You cannot give any control signal to control the diode. It is being controlled by the power circuit. That is uncontrolled switch. Diode is an uncontrolled switch. Second is the semi-control switch. Is the semi-control switch means silicon control rectifier, SCR, triac. These are examples of the semi-control switch. Therefore, for switching on the device, on process is being controlled by the control signal, but off the process of switching off, that is not controlled by the control signal, rather than it is being controlled by the power circuit. You have to bring the current below a certain value of the current. We will see that one, it is a holding current. If you bring the current less than holding current, that gets switched off in the case of SCR. Therefore, this is a semi-control switch in which switching on can be controlled, but switching off is being controlled by controlling the power circuit. And the third category is that control switch. In that one, both switching on as well as switching off are being controlled. For example, BJT, bipolar junction power BJT or bipolar junction transistor, then MOSFET is there, IGBT is there, etc. Different these switches can be switched on as well as switched off by controlling switching, by giving the switching signal. It can be controlled by using the control signal. You can control switching on as well as switching off process of these semiconductor switch, BJT, MOSFET, IGBT, etc. Here SCR is a semi-control switch, a diode is an uncontrolled switch, BJT, MOSFET, IGBTs are it is a control or fully controlled switch in which you can control both switching on as well as switching off. Therefore, these are the three categories of semiconductor switches. In this one, we are comparing the three controlled semiconductor switches like bipolar junction transistor, MOSFET, and IGBT. First one, it is BJT is a current control device or switch, and MOSFET as well as IGBT are both voltage control switches or voltage control devices. And then drive circuitries, it is very complexity is less, but in this case little more complex, high it is the complexity. Then switching speed is, it is relatively slow, and this is very slow, and this is slow, and this is very fast, and this is medium. And the switching frequencies, this is used for a very few hertz, but this is up to 1 megahertz for, and this is less than 50 kilohertz. Therefore, more high frequency application, very high frequency application, MOSFET is preferred compared to other two. Therefore, these are the forward voltage drop, low, medium, low. For we are comparing the control switches like bipolar junction transistor, MOSFET, and IGBT for a. Anyway, we will be coming later to all these switches. Therefore, these are control switches like, and we are comparing this BJT, MOSFET, and IGBT. And the pictorial it is given. BJT it is a PNP and NPN. There are two types of bipolar junction transistor. Similarly, MOSFET, if you see, N channel MOSFET is the, P channel MOSFET is the, and here this is simple as mainly the when we shown the symbol of a IGBT, N channel IGBT is shown. Power electronics is the control and electron devices are the devices which are used to control and convert the electric power. For control and conversion of the electric power, that process is done by power electronics switches. For power electronic circuits can be classified into, based upon the type of source and the load here. If you have a fixed AC and if you want to get a variable DC, then we will be using for a phase control rectifier. If you have a fixed AC and you want to get a variable DC, then you will be using a control rectifier will be using. Then if you have a fixed DC and if you want to convert into a variable AC, then we will be using for, we will be going for inverter. You have a fixed DC, but you want to get a variable AC, because if you have a DC source is there, but here you are using an AC induction motor, then you will not to vary the voltage as well as frequency. Then you can use an inverter, that is a variable voltage, sorry, a fixed DC voltage that is converted into a variable AC voltage. That is done by inverter. Then third category is a chopper. Chopper means that if you have a fixed DC and you want to convert to a variable DC, then it's a DC to DC converter. That is, in that case, the power modulator is working as a chopper. Then another one is that AC to AC controller is there. You have a fixed AC, but you want to variable you want to get a variable AC with a variable voltage and variable frequency, then we'll be using AC voltage controller, or we can use a cyclo converter. Therefore, depending upon the input AC or DC voltage and depending upon the output AC or DC load here, the role of the power modulator will be changing. Rectifier, it can be working as a rectifier, it can work as an inverter, or it can work as a chopper, or it can work as a AC controller or cyclo converters. This is to use the power electronics device as a switching device. Is an example to show the use of power electronics device as a switching device. Is an example. In that case, first our purpose is that you have a fixed DC of 100 volt is there. You want to get a output voltage across the load as 50 volt. Therefore, you have to convert a 100 volt input into a 50 volt output, and the load resistance is the 5 ohm load resistance is there, and the current through this load is equal to 10 amperes. That is our requirement. This is our requirement. Consider an example of DC to DC converter. A 50 volt DC is required. You want to get a 50 volt across the load and a 5 ohm resistor, and the current through the input voltage equal to 100 volt and the current through the load equal to 10 amperes. When a 10 ampere is flowing through a 5 ohm resistor, you want to get an, or you'll be getting a 50 volt and input voltage equal to 100 volt. This is a DC to DC converter that converts the 100 volt into 50 volt. Okay, this is our aim. What are the first case? What we are assuming is that if you have a 100 volt is there, you want to get a 50 volt, means that assume that you are connecting a variable resistor. You are connecting a variable resistance. This is a 5 ohm resistor, and you are connecting a 5 ohm resistor also here. Then 100 volt, if you divide, it will be dividing as 50 volt here, 50 volt here. And in that case, there will be a power dissipation here. The power dissipation, this is equal to 50 volt is coming here, and here the remaining 50 volt comes here, and the 5 ohm resistance is there. The power dissipation, 500 watts of power is being dissipated here. Therefore, here you are getting, of course, you are getting the output voltage equal to 50 and 10 ampere is there. 500 watts output is there. The same power is being dissipated in the resistor also. Therefore, efficiency, in this case, efficiency will be getting 50% of efficiency. Now, the way this is same thing can be realized by using a transistor when it is working in an active region. When a transistor is working in active region, as we have already seen, let's say linear power supply, we are controlling the base drive of the transistor so that it is working as a variable resistor. We are controlling the resistance between collector and emitter and making this output voltage 50. The remaining 50 voltage is being will drop across the transistor, so that here the power is dissipated 50 volt into 10 ampere. 500 watts is being dissipated here. 500 watts is dissipated, and that is given to the load, and again the efficiency is equal to 50%. Therefore, the transistor is operated in active region. In this case, the transistor is operated in active region, and the voltage drop across the transistor is 50 volt. 50 volt is dropped here. Remaining 50 volt is available across the load, and the power dissipation is equal to 50 volt into 10 amperes. Therefore, 500 watts is being dissipated in the transistor. Therefore, efficiency is 50%. Now, coming to the third case, that we are using a switched mode. Then semiconductor switch is using. Semiconductor device is using as a switch as such. It is something like a buck converter. It is a buck converter. It is just like a switch we are using here. When for example, this is a switch here. 100 volt is there. This is the load. 5 ohm resistor is there. Now assume that this switch is connected directly to that volt. Then you will be getting the voltage same as the 100 volt. Now after some time, you will be changing over from this point to this point. Therefore, you will be getting 0 voltage here. Now this is being repeated for turn on period as well as T off period. During turn on period, you will be getting the 100 voltage. During turn off period, you will be getting 50 volt, and that is available. And that voltage, that available voltage, is filtered using an LC filter, so that you will be getting here 100 volt you are applying. By controlling the on-off period, duty ratio we call it as, by controlling the duty ratio, you are getting the output voltage that is equal to 50 volt here. For this is actually, in this case, the semiconductor switch, or that is used as, the semiconductor device is used as a switch. Rather, here it is using an active region, but in this case either it will be in saturation just like a on switch, or it will be in a off switch it is used. Therefore, in this case, the power dissipation is minimum and the efficiency is large. It may be more than 90 percentage. For during this period, T on period, the switch will be positioned in the position 1, and during T off period this will be in the position 2, and during on period you will be getting 100 volt, during off period you will be getting 0 volt, and then we are finding out by filtering, connecting an LC filter, you are taking the average of that one, that will be equal to 50 volt. Therefore, by this, in this case, the semiconductor switch is used, switch is using as, the semiconductor device that is using as a switch. This already we have seen in a linear power supply. The semiconductor device is a transistor that is operated in active region. By controlling the same thing here, the AC voltage is stepped down using a transformer, and that is rectified, that is filtered, and this is the load. And by controlling the base drive, you are controlling the resistance between collector and emitter. It is working as a variable resistor. Here the power is being dissipated and the efficiency is very less. In linear power, this is called the linear power supplies. Transistor act as an adjustable resistor where the voltage difference in voltage, that is the difference in voltage of this voltage minus this one, the output voltage Vd minus V0, that voltage is the output voltage appears across the transistor, and that causes the power loss. The difference in this voltage and this voltage, that will be across the transistor, that will be causing the power loss. That is in linear power supply. That transistor is working in a active region. These are the pictorial representation of the linear power supply. We can see that size of the power supply is large here because the power dissipation is large, or the efficiency is very less. Therefore, in linear power supply, the advantage is that, one advantage, it's a very simple design, cost is less, but the disadvantage is that the efficiency is very less because of the losses. Transistor is working in active region, efficiency is very less, and as well as the bulky, it will be bulky also because the input side, the transformer is working at the line frequency, the size, weight, volume, etc. is very large, and the efficiency is also very less. These are the disadvantage of linear power supply. But in the switching power supply, as I already explained, the semiconductor device is working as a switch. It will be either in saturation or in cutoff, and in that case the advantage is that weight is less because it is operating at a very high frequency. Size of the inductor will be very less, therefore volume, weight, etc. will be very less, and efficiency also much higher than the linear power supply because losses are very less. The the switching loss is very less. That is why the efficiency will be very large. That is only the one disadvantage is that there is a of course one is relatively cost is high, and the electromagnetic interference, because it is operating at a very high frequency, few kilohertz, maybe 10 kilohertz or 20 kilohertz, that kilohertz it is working. That is why the electromagnetic interference would be large. Now, since the losses are less and the size is less and the size of the inductor is very less, we can see that one, say this is equal to 2000 watts switch mode power supply, that is this much is only the size, or this is 25 watts and this is 60 watts, because size is very less. That is because of the loss is very less, since the semiconductor switch is working and semiconductor device is working in as a switch, either on or off. Therefore, the loss are less. That is why size is very less. In switching power supplies, the semiconductor switches are, the device are using as a switch, and because of that one, efficiency, because one aim is that it increases the efficiency because loss is very less, minimizing the loss, and as well as light weight is there, because since it is operating at a very high frequency, the size of the inductor is less, and once size is less, volume is less, weight is less. Therefore, the weight is less and efficiency is more in the case of switch mode power supply. Then we are using the switches like MOSFET or IGBTs are used, that will be either on or off. It is working either switching on or switch off, and we can see that only thing, the side effect is the electromagnetic interference is the effect as such. For the components used as, either the switching device will be using MOSFET or IGBT, and the gate driving circuit is required, and the modulation techniques, different modulation, pulse width modulation techniques will be using in the switch mode power supplies. Therefore we have seen the when the semiconductor switch is used as if semiconductor devices are used as a switch, the switching losses are very less, and but when it is the device like bipolar junction transistors used in active region, the losses are very large. That causes the size will be large, and the size, weight, volume, etc. will be large. Therefore, that is the advantage of switched mode power supplies compared to the linear power supply.